Hello folks, and welcome back to our next lesson. Today we're going to be covering absolute value functions. So we're going to be looking at absolute values. We're going to get started here by trying to figure out what the absolute value function looks like. To get started with that, let's just do a table of values. Remember, when in doubt, you can just create a table of values. So we'll create our x and y's. And let's go from -3 all the way up to 3. So the absolute value, right, this is y is equal to absolute value of x. For -3, what's the absolute value of -3? It's +3. -2, it's going to be +2, +1, 0, 1, 2, and 3. So now we can place these onto our graph. Starting at 0, 0, looks like we go up by 1 each time we move left or right. If we wanted to continue this on, we just go up to there and create our graph. So this v is the basic form of the parent function, or the basic function y is equal to absolute value of x. Now, a couple of pieces of information that we need to know here. The line right down the center of the v here, we call that our axis of symmetry. Because if we were to fold it over the axis of symmetry, we would find that it always stays the same. Our axis of symmetry in this case is going to be the line, the vertical line, x is equal to 0. Now the point where the axis of symmetry meets the actual graph, so right here at the very bottom, we call that our vertex. So the vertex is the peak or the minimum point of an absolute value function. Generally, the vertex takes the form of an ordered pair, and we'll write that ordered pair as h, comma, k. Why h and k? Well, we'll see that in just a second. But our vertex for this one is going to be 0, comma, 0. So we were dealing with transformations yesterday. We're going to transform these, but we have some important information now. This is what our parent function looks like. We know we have some line that we can fold the absolute value function across, and we know our vertex takes the form of h, k. Now let's apply what we saw about transformations yesterday. This was the form that we saw our transformations take yesterday. F of x is equal to a times f of x minus h plus k. Yesterday we actually dealt with this as plus h, but the real form is actually minus. This is how we get rid of it flipping sideways. Because if it's just minus 2 now, we still know we go to the right, but the minus is just sort of included in here. Same thing as what was happening before, these all affect the same things. So a is going to be our vertical stretch, or our vertical compression. And the important thing to remember here as well is each of our changes in y, where we go up 1, they'll get adjusted, they'll be changed, or they'll be multiplied by a. So each change in y is multiplied by a. H here is the same value as we had before, so this moves, or it translates our function left and right. So h translates left or right, except for this time, R-I-G-H-T, promise I can spell. Except for this time we have the minus out here. So a minus 2, right, the minus is just here, so the 2 is going to be positive. And think of this more or less in the same way. K translated, or it moved our graph up and down. Now you'll see we have an h and a k in this version. We said that our vertex took the form of h and k. This h is the same as that. This k is the same as that number. So that's all we need to do these equations, to find out the vertex. Great, so using this lesson that we had yesterday, let's figure out what we expect each of these to do, and then we'll graph them. So this is x plus 3. If we rewrote this using our new minus rule, this would be the same thing as the absolute value of x minus a negative 3. So our vertex we expect to be at minus 3. Now what does this do? Well, this is inside, so we're going to shift. Let's see, this is positive, so it'll be left 3. Or if we look at it this way, right, this is why we like the minus, we're just moving it minus 3 horizontally. We're translating it minus 3 horizontally. What about this one? While we're looking at it, we see that we have a plus 3. That looks like our k, so it's going to shift up 3. Right here, that 3 looks to be in the value for a. So a is our vertical stretch or compression. This is larger than 1. Right? Stretch is a is greater than 1, whether positive or negative. Compression is a is smaller than 1. So this is going to be a vertical stretch of 3. And then finally, we have a minus. What did the minus do yesterday? Well, it flipped the function upside down. But we can also say, the fancy math way of saying that is this reflected it across the x-axis. So we reflected it across a horizontal line. And then same thing, so reflect over x-axis. Great, and now we could put these into our graphing calculator. These two should be familiar, so I'll let you do those on your own. However, for this one, how do we include that vertical stretch? Well, if we have this going out to 3 each direction, we haven't moved our vertex. Our vertex is still 0, 0, so we're going to start at 0, 0. But then when we went to 1 or 2, what happens when we put a 1 in? Well, this becomes 1 times 3, so we go all the way up to 3. And this is what I mean. Each time we go normally where we're supposed to, it's going to get multiplied by whatever that number is outside. So this goes all the way up to 3, and it looks skinnier than our last graph. Meanwhile, with the reflection, in case you're not comfortable with that, all we're going to do, we start at the same place, our vertex hasn't changed, but now, right, if we went to positive 1, what would happen if we put a positive 1 in for x? Well, this would become positive 1 times minus 1, so this is a negative 1. Right? We've just flipped this, or all of our points get changed across the x-axis. They get reflected. Great, so using this, let's try to analyze all the changes that happen to this and how they'll affect our graph. Looking at this, we have a minus out in front. We have a number out in front, we have a minus 3, and we have a plus 1. Let's go with the easy part. We have the plus 1, so this means we go up 1. The minus 3 means we go right 3. The minus means we flip vertically, which remember is the same thing as reflecting over the x-axis. and we have a 0.25. The 0.25 is going to vertically compress our equation by 1/4, right? 0.25 is 1/4, so this is 1/4 or a quarter. Great, let's put all of this information into play. Let's start by trying to find our vertex. How have we moved? From 0, 0, we've moved right 3 and up 1. So our vertex is going to move from 0, it's going to move right 3 and up 1. So we're going to move right 3 and up 1. Then we said we flip this, so it's going to go down instead of up, right? This is going upside down. And we have to reduce all of our values by 1/4. So normally we'd go up by 1 in either direction. But the minus means we're going down, and the 1/4 means we're not going down by 1, we're going down by 1/4. So instead, it's going to be really small there. It's going to be the same going the other way. It's only after 4 of these away that we will actually reach the next point down. We draw our graph, and that's what it looks like. Now we have a couple more practice problems as well, just to get familiar. Each of these has some transformations and has all of those. Let's go through a couple of these. Starting with this one, we have a -2, which is going to bring us right 2 and a +1. So right 2 up 1, our vertex is going to be 2, 1. So let's go to 2, 1. Doesn't look like anything else has changed, so we're just going to move the graph with our nice little comfortable V just up to the point 2, 1. For this one, we have a +2. Plus inside means that we have to flip this. We're going left 2, but it doesn't look like we've changed anything for going up or down. So our vertex is going to be -2, 0. Great, from this point, no negative, so we're still going up. Except for this time, we multiply all of our changes by 3. So instead of going over 1, up 1, we're going to go over 1, up 3. And over 1, up 3. And there we go. We already did a flip. Let's move on to another hard one. So we have a -1, meaning we're going to go right 1. We have a +2, so we're going to go up 2. So we'll go right 1, up 2. Our vertex is going to be 1, 2. Now at this point, we have a minus. So we're going to be looking to go down on this graph instead of up. Minus means we do that. And we have a 0.5, meaning that all of our changes, instead of going up 1, or in this case down 1, we're going to go down by 0.5 each time. We're going to multiply each of our steps by 1/2 instead. So we go down 1/2, we go down another 1/2, and so on. And we get a graph that looks a little wider, more expanded than our last one. All right, that's all we have for this lesson, so go ahead and get working on the homework.